Elon Musk just said full self-driving version 14 feels almost sentient. Is that just hype? Or is it the moment Tesla's AI really turned a corner? In this video, I break down the tech behind the new release. And yes, we're also talking about that viral Optimus dance video that proves Tesla's AI strategy is actually working. So here we are in early October, and Tesla begins rolling out full self-driving version 14. It's not just a quiet update. Elon Musk is calling it transformative. On screen, you'll see a timeline of FSD releases, with version 14 highlighted. That context matters, because this release arrives with bold promises. Now, let's translate the claim. When Musk says almost sentient, he doesn't mean consciousness. He means the driving experience feels more natural. In practice, this is about smoother turns, fewer robotic stops, and a system that anticipates like a human. Imagine showing a side-by-side driving clip. Version 13 hesitates, while version 14 glides. The difference is subtle but powerful. Technically, what changed? Neural networks got deeper and cleaner. Tesla reduced reliance on hand-coded logic and leaned harder on end-to-end training. That means fewer driver interventions. In fact, early testers are reporting far less takeover anxiety. On screen, you'll see a chart showing interventions per 100 miles dropping sharply from version 13 to version 14. And then there's Optimus. The viral video shows the robot dancing, and not just in a scripted way. It balances dynamically, responds to pushes, and looks, well, uncannily smooth. Let's put that clip on screen. Why does this matter for cars? Because it's the same AI stack at work. The real leap is that Optimus no longer needs a tether or external support. It's balancing itself in real time. For robotics engineers, that's huge. On screen, show a comparison. Earlier Optimus tethered versus today's freestanding, walking, and dancing. This proves Tesla's AI can handle dynamic, unpredictable environments. But here's where the story takes a turn from impressive engineering to a paradigm shift in AI. The agility of Optimus and the navigation of Tesla's full self-driving aren't two separate projects. They are two expressions of a single unified mind. The very same foundational neural networks that allow Optimus to work are the backbone of FSD. The AI architecture is fundamentally agnostic. It doesn't learn how to drive or how to walk. It learns something far more profound. A predictive model of the physical world from visual data. Think of it like a human learning the concept of balance. Once you understand it on a bicycle, learning to snowboard is exponentially easier. Your brain applies a universal principle to new hardware. For Tesla's AI, the hardware is either a set of wheels or a pair of legs. This shared architecture creates a powerful feedback loop. First, data flows from the cars to the robot. Tesla's vehicle fleet has driven billions of real-world miles, creating an unparalleled dataset for navigating our chaotic world. Every mile is a lesson, teaching the AI about everything from a pedestrian's subtle cues to reflections on a wet road. When transferred to Optimus, the robot inherits this nuanced understanding, giving it a massive head start in perceiving and navigating any environment. But the data flows both ways. A car mostly avoids the world, while a robot must physically interact with it. Optimus has to learn the difference between a rigid box and a soft bag, how much force to apply to an egg versus a metal part. This develops an incredibly high-fidelity understanding of physics and material properties. This granular data then enriches the AI's core world model. The car's AI, armed with this deeper physical intuition, can make better predictions about debris on the highway, or the dynamics of a potential collision. What we're witnessing is the creation of a collective intelligence. Every task Optimus performs refines the FSD algorithm, and every mile a Tesla drives makes Optimus smarter. This is Tesla's ultimate strategic advantage. A single, universal AI brain that learns from an ever-expanding fleet of diverse machines. It's a shared nervous system for a new species of autonomous machine, creating a flywheel of intelligence that accelerates with every car sold and every robot deployed. Tesla has confirmed internal deployment of Optimus will happen by 2025, with commercial availability targeted for the fourth quarter of 2025. On screen, let's show a timeline roadmap, with factory use first, followed by commercial sale. That date is closer than most realize. And here's where the story pivots, revealing the true scale of the ambition. For years, The world has seen Tesla as a car company, a very successful, disruptive one, but a car company nonetheless. But to understand Tesla's future, you have to look past the sheet metal and see the vehicles for what they truly are, the largest distributed sensor network on the planet. Every Tesla on the road, now numbering in the millions, is a sophisticated data-gathering robot on wheels. Equipped with a suite of cameras and sensors, each car collects terabytes of real-world data every single day. We're talking about navigating complex urban intersections, reacting to unpredictable pedestrians, and handling adverse weather conditions. This isn't sterile, simulated data, it's the messy, chaotic, and infinitely valuable data of reality. This fleet acts as the eyes and ears for a single, unified artificial intelligence, creating a data moat that competitors simply cannot cross overnight. They would need to sell millions of sensor-equipped cars and wait years to even begin to catch up. This torrent of information flows back to Tesla's nerve center, where it feeds the insatiable appetite of its AI training infrastructure. The crown jewel of this operation is the Dojo supercomputer, a custom-built machine designed for one purpose: to process video data at an unprecedented scale and train the neural networks that power full self-driving. This is a feedback loop of epic proportions. The fleet encounters new scenarios, the data is used to retrain and improve the AI, and the updated software is pushed back out to the entire fleet over the air. The system gets smarter, collectively, with every mile driven. But even full self-driving, a monumental challenge in itself, is just a stepping stone. It's the proving ground for the real endgame, a universal AI and robotics platform. The same AI that learns to navigate the world in a car can be adapted to navigate the world in a different form factor, a humanoid robot. Enter Optimus. This isn't a gimmick, it's the logical next step. By solving for real-world navigation and interaction with FSD, Tesla is building the foundational AI for a general-purpose robot. A robot that could one day perform dangerous, repetitive, or boring tasks in factories, warehouses, and eventually, our homes. The potential market for useful autonomous labor is orders of magnitude larger than the entire automotive industry. This is why traditional automotive valuation metrics fall apart when analyzing Tesla. The ceiling for a company that sells cars, even millions of them, is fundamentally capped by manufacturing capacity, material costs, and cyclical consumer demand. It's a tough, low-margin business. But the valuation for a company that successfully develops and deploys general-purpose artificial intelligence? That's a different paradigm entirely. It's a business of software, of licensing, of intelligence as a service. The marginal cost of deploying that AI into another robot or another system is close to zero. It's the transition from selling physical atoms to selling infinitely replicable bits of intelligence. The pie chart isn't just changing, the entire pie is expanding exponentially. The car business, once the whole story, becomes a single foundational slice of a much larger AI-driven future. When we look back, the release of full self-driving version 14 and the viral videos of Optimus dancing might seem like separate, exciting milestones. On one hand, a software update that finally feels like a true leap in autonomous capability. On the other, a robot showcasing a newfound grace and balance that captured the world's imagination. But to see them as distinct events is to miss the forest for the trees, to mistake the symptoms for the cause. The real story, the one that redefines Tesla's entire mission, is how these two threads are inextricably woven together. For years, the automotive business has been more than just a way to sell cars. It has been the largest, most complex data gathering and AI training program in human history. Every mile driven by a Tesla, every intervention by a driver, every piece of video data processed from its 8 cameras, it's all been feeding a singular, massive neural network. This network wasn't just learning to drive, it was learning to perceive, interpret, and navigate the chaotic, unpredictable physical world in 3 dimensions. The car was simply the classroom, a safe, wheeled vessel for the AI to learn within, protected by a steel cage and a human supervisor. Now, that AI is graduating. Optimus represents the moment this intelligence is unshackled from the vehicle and given hands and legs. The same core brain that learned to navigate a 4-way stop in San Francisco is now learning to manipulate objects in a factory. This is why robotics is the ultimate prize. The global automotive market is measured in trillions of dollars, a staggering figure. But the market for autonomous humanoid labor? That's an order of magnitude larger. It touches every single industry: manufacturing, logistics, healthcare, elder care, exploration, and even domestic chores. We're not just talking about replacing a car, we're talking about fundamentally augmenting the entire human workforce. This is why the dancing is so significant. It's not about the hardware, it's a demonstration that the software, the AI, is becoming generalizable. This isn't just hype, it's a glimpse into a future where Tesla is less about the vehicles it sells, and more about building the foundational intelligence for all autonomous machines. The car business becomes the training ground, the Dojo supercomputer becomes the university, and Optimus becomes the first graduate in a new class of embodied AI. We are witnessing a pivot from a hardware company that uses great software to an AI company that uses hardware as a vessel and a tool for training. The real product is the brain. And as that brain continues to learn from an ever-expanding fleet of cars and robots, we're not just watching a company evolve, we're watching the birth of an entirely new economic paradigm, one built not on information, but on autonomy.